Hello and welcome to my YouTube channel. In this video, I'm going to show you how to work with the STM CubeMX IDE. This is the introductory video for this particular IDE. So without any delay, let's start the video. So in the last two videos, I have discussed about STM CubeMX IDE, how to install it and how to configure the STM CubeMX IDE. So when you start the IDE, you will encounter this particular view. Now, let us briefly look into the features of this particular IDE. First of all, in the File button, you will get the facility to create a new project or load any project which you already have developed. In the Recent tab, you can see all the projects that you have created using CubeMX IDE, the recent projects. Okay, now here in the left area you can again see existing projects, so recent opened projects. So using CubeMX, if you have developed any project, then those lists of projects will be showed here. Now coming to the window button, using this you can make the window or this particular appearance smaller, medium or larger. Right now I am using medium because this suits my computer's appearance. Now, to create a new project, you can choose any one of these options. First option is to start the project using microcontroller selection. Second option is using board selection. These boards are provided by the ST microelectronics. So you can choose the board, you can choose the microcontroller, or you can choose projects which are actually available in the example section. I would recommend you always to, whenever you start the CubeMX IDE, you should always go to help and check for updates. So when you click the checks for updates, here it will show all the updates required by you. Because my system is right now updated, so there is no list which I need to be updated. Second way to update the system as STM CubeMX IDE is from this section, where you can check for updates by clicking on this button. Because I don't have to update anything now, therefore this particular button is disabled. If you want to install any particular package, then you can use this button, install/remove. If you click it, it will show the list of all the microcontrollers packages which you can install. So depending on your microcontroller board, you can install any of these packages. For example, if your board belongs to STM32F0 family, then you can go and download these packages. For example, in my case, I am using STM32F4. So you can see here, I have installed STM32CubeMCU package for STM32F4 series. And these are the previous versions of those packages. Apart from that, you can go to this particular tab, STM Microelectronics, and you can install another packages like Xcube AI, Xcube Algo Build. These packages you can use to design projects related to a particular area. For example, Xcube AI, you can use it to develop projects for applications using artificial intelligence. Similarly, AZ-RTOS, you can use it to develop projects in the RTOS and so on. So right now I'm not looking into these applications, so I am restricting myself only for STM32F4 package. Apart from that, you can visit these particular tabs and you can install those applications if you find it important. Now, after installing the package, you can just close this window and let me show you how to select or start a project using microcontroller selection. For that, you have to click on this button, Access to MCU Selector. When you click it here, it will open a window which will list all the microcontrollers which are provided by STM. So it is just checking what are the software packages to be updated. After that, it will open a new window which will list all the microcontrollers available with the STM. For example, if I drag it up, you can see these are the microcontrollers which are provided by STM, and the list is very long. Okay, so if you know your microcontroller, you can just go to commercial part number and type your microcontroller STM32F446RE. So these are the microcontrollers which are available in the F446RE family. So this way you can select your microcontroller and you can start your project. Second option is to go for board selection. So let me close this. And you can start a project by choosing the board that you have. For example, click here, Access to Board Selector. And then you again reach to the same window. So you can select the microcontroller from this tab, or you can select the board and just type the board that you have, STM32F44. So now it shows, no, you don't have the board. Actually, you can just type F446RE and it shows Nucleo F446RE. And in the bottom here in the right, you can see Nucleo F446RE board is displayed. Once you click on that, the details related to the board appears on the top. So here you can read STM Nucleo 64 development board with STM32F446RE microcontroller unit, supports Arduino and ST Morpho connectivity. And when you scroll down, you can read all the features which are available with the board. So after looking at these particular details, you may start a project. You can check a bigger image by clicking on large picture, scroll it up and down. You can see all the pin details here. You can go for document and resources. So here in the documents, you can download technical notes and articles, training materials, user manual, and presentation, and so on. If you are interested in the data sheet, you can go to the data sheet and download the data sheet here. So to start the project, you just have to click Start Project. So you click Start Project and it will start the project. So here it shows initialize all peripherals with their default mode. If you are interested in developing a project with all the default mode pins to be activated, you can click yes, or you can, if you don't want to activate the board with default mode, you can click no. For time being, I am just clicking yes, and this will load the basic project settings which are related to the microcontroller board. So now we can see a new window which shows a lot of things in front of us. For example, here you can go to home on the left top, then STM32CubeMX Nucleo and Untitled pin configuration and all. So first of all, let us talk about the pin out and configuration. So we are in this tab. Of course, there are multiple tabs here. We can go through them one by one. So pin out and configuration. Once you click on the pin out and configuration, in the middle you can see the microcontroller that you are going to use. So in our case, we are going to use STM32CubeMX which is 64-pin microcontroller. And we can see many pins are activated already because we selected the default option. So this is the pin out view. In that we can see all the pins and what are the pins going to do. For example, this pin is for power, VBAT, battery, PC13, push button, RCC oscillator in, RCC oscillator in, RCC oscillator 32 out, and so on. So these pins have already been activated because we selected the default view or default selection. Now let us briefly look at the details about these pins. So remember, these pins are having different colors. For example, here VBAT is in yellow, PC13 is green, and then yellow, and so on. So generally, yellow buttons are used by the power section. So VBAT, VDD, VSS, ground. So power buttons are yellow. Okay, you can see here all these yellow buttons are related to power supply end. Now, second option is the green buttons. Green buttons are generally GPIO pins. So general purpose input output pins. Then we have orange pins. These orange pins are system pins related to the system. For example, here this pin PB3 is right now is used as JTDO SWO. Okay. Similarly, grayish pin PC0, PC1, PC2, PC3, all these gray pin are to be used or they are not right now activated. We can use these pins for different purposes like for any GPIO application or any peripheral related application. We will look into that. Apart from that, these pins, grayish pin, can be used for GPIO as well as for peripherals. Now, how to actually know which pins to be used for our project? For that, you can click on any of these pins. For example, right now I just clicked on PA10 and PA10 shows all the features which you can enable using PA10 line. So you can use PA10 for reset state, or you can use it for DCMI, timer 1, channel 3, USART 1 receiver pin, GPIO input pin, GPIO output pin, and so on. So it is very easy to know what are the features available with a particular pin. For example, PC0 can be used as analog to digital converter 1, interrupt 10, analog to digital converter 2, interrupt 10, and so on. So different pins can do different functionalities. Just by clicking on the pin, we can see all the features which can be enabled using these pins. But one thing has to be remembered, that once you set one of the features, then that pin cannot be changed in the middle of the project. For example, if I make PC6 to work as a GPIO input, then for the whole project, this PC6 pin should remain GPIO input. In the middle, you cannot go, you shall not change the pin to work as timer 3 channel 1 or any other application. So once you have set the pin for a particular configuration, then you should not change it in the middle of the project. So now the question comes, how to set or change the pin. For that, it is very easy. Click on the pin and then you can just choose application which you want to enable on that. For example, let me show you here. If I want to make PA6 to work as a GPIO input, I just have to click it and then go down and make it GPIO input. So once I selected it and configured it as a GPIO input, you can see here the pin PA6 now has configured as GPIO input. Now to change the name of the pin, for example, here the name is GPIO input. If I want to change it, I can just go here, right click on the pin and enter user label. So I can just go and change the name. For example, I can make it, because it is an input, suppose I want to call it switch underscore 1 and click enter. So now PA6 will be known as switch underscore 1. It is your choice. You can name it according to your requirement. For example, you can also call it SW1. Okay, so switch 1. So in this way, we can rename the pins and we can use them according to our requirement. Now coming to the other facility which you can extract from this particular IDE. So suppose you want to configure the pin PB10. Okay, just for an example, suppose you want to change to PB10 to work as SPI2 clock. Okay, so for that you just have to click on the PB10, left click and go down, click on the timer 2 or SPI2. So let me make it SPI2. Now to configure this SPI2, in the left pan you can see there are multiple subtabs like system core, analog, timers, connectivity, multimedia, computing, middleware and so on. So you click on them and you can see the different system related applications that you can use. For example, DMA, GPIO, NVIC, RCC. So we will cover all these features later. Similarly, you can check here ADC 1, 2, 3, DAC. So analog app operations, analog to digital, digital to analog converters. Then you can click on timers. So there are list of timers from which you can use these particular timers. Similarly, multimedia and computing, and then middleware packages, which right now we are not going to use. So in this way, we can explore different features related to the pin. For example, now I have just configured PB10 to work as SPI2 SCK. So this is related to connectivity. So I will go here and I can see here on the in the list that I have activated the SPI pin. Okay, so in this way we can cross check which pin has been activated and what kind of features we are going to use in the project. Okay, so to zoom in or out, you just have to scroll the mouse. So by scrolling the mouse you can zoom in the pins, and by scrolling the mouse in the opposite direction you can zoom out also. Okay, so now one more feature. For example, here I have configured PA6 as switch 1, and if I need to change the PA6 to some other, or to make the switch to work on any other pin, then what I can do is just click on control. That means keep the control button pressed and click on the pin which you want to change. Okay. For that, by that you can change the location of the pin from one location to another location. Let me just show you. So control, left click, and it shows the options to move the switch to any other pin. For example, you can see now we are able to see many pins which are blinking. So we can shift it to PA7, PC4, PC5, because we can configure any other pin which are blinking, okay, to work as input pin. So suppose I want to shift switch 1 to PB0, I can just drag it and leave it there. Let me show you again. So suppose I want to switch the switch 1 from PB1 to any other pin, any other location. In that case, just press Control, click on the button and hold the left mouse, and it will start blinking the pins which can be used as switch 1 or to be used as GPIO input. I can shift it to any other location just by dragging the mouse and releasing the left click. So now the switch has been shifted to PC9. Let me take another example. For example, let me check PA7, and in the PA7, suppose I want to activate PA7 to work as SPI1 MOSI pin, which is related to SPI communication. So I have activated it by left click, SPI MOSI. Now PA7 SPI MOSI. So now we can see PA7 has been configured as SPI MOSI pin. Now if I want to check which other pins can work as SPI MOSI, I just have to press Control and click on the left button, hold it, and you can see PB5 can be configured as MOSI. So I just have to drag the mouse to PB5 and release the left click, and you can see the PB5 can work as SPI MOSI. In this way you can shift the functionalities from one pin to another if needed. Another feature about this particular STM32CubeMX is the clock configuration, which is considered to be one of the most difficult part in any microcontroller. The clock configuration window can be reached by clicking on this particular button, clock configuration. With this, we can see the whole list of clock related activities in the microcontroller, and we can set the clocks according to our need. For example, right now we can see the source is input frequency provided by LSC, and input frequency can be provided using crystal also. So high speed enabled, low speed enabled. If you want to see the effects of changing the input frequency, so here you can see the input frequency can be configured between 4 to 26 megahertz. If I make it 6 megahertz and click enter, suddenly all the peripherals features will change accordingly. This software or this IDE helps to automatically set all the features that we require. For example, here it shows HCLK can go up to 180 megahertz, and right now we are running that clock at 84 megahertz. So suppose you want to change the clock speed to 120 megahertz and press enter. So the the software will automatically reconfigure the clock speed, and it will automatically assign the clocks according to your requirement. For example, I have changed it to 120, and you can see here the clocks for peripheral APB1, APB2 and all will automatically change. For example, if I want to go to the maximum clock speed 180 megahertz and click enter, you can see these clock settings will automatically change. Let me make it 180, enter. So here you can see the clock speed have been changed. So in this way, I can easily reconfigure the clock, and the software will take care of all the settings for me, and I don't have to worry about the clock settings or clock configuration. It is one of the most easy approach to configure the clock. With this, I would like to end the lecture. Let me briefly summarize what we have learnt in this lecture. First, we saw how to start a new project. For that, we opened the IDE. Okay, we checked for updates. We tried to install the required packages, and then we selected the board for our application. After installing the package for the board, we can start working with the project by three options. First option is to start the project by using a particular microcontroller. Second option is by choosing the board. Third application or third approach is by choosing cross selector. I have not discussed about this part anyway. Then to start a project by using a board selection option, you can just type the board that you have. For example, in our case, we had Nucleo F446RE. Just type it. In the bottom right, you will see the board. Click on that. On the top right, you can see all the details related to the board. You can scroll down to go through the features of the particular board. Then we can start the project just by clicking start button. If you want to see larger picture, click on large picture. If you want to see through or go through the documents related to the board, you can just click docs and resources and so on. After clicking the start button, you will be informed about to initialize the project by using default mode. In this mode, the microcontroller board will get the assignments to the pins which are in default mode. We can select yes or no depending on our choice. Second option, we can select the microcontroller and then start a project. And then we saw if we have initialized the project by default mode, then the CubeMX IDE assigns default pins in the project. Then we talked about the different colors which are assigned to the microcontroller pin. For example, yellow pins are for power, green pins are for GPIOs like input and output, orange pins are related to systems operation, grayish pins are for system pins which can be used for GPIO purpose also. These pins can be configured to work in multiple ways. Okay, so to know what are the different features you can use from a particular pin, you just have to left click and the list of different features will automatically appear. And according to your choice, you can just select one of the options listed. And then we talked about how to change the pin from one location to another location, or to use any other pin from one location to another location. For that, you just have to click on the button by holding the control button, and then automatically the software will show you which are the alternative pins which can be assigned the similar facility or feature. Just drag your mouse to that pin and release the left button, and you can reassign the pin from one location to another location. This operation we saw. And if you want to clear all the default settings, of course you can go to clear pinouts. We will look into this feature later. And we saw how to change the name of the pin. For that, you just have to right click on the pin, select user label, and type the label you want to assign to that particular pin. Simple as that. And then we briefly talked about how to go to this clock configuration tab and use basic features of clock configuration. We will look into these sections in deep in the upcoming videos. Okay, so with this, I would like to end the lecture or end the video. If you have any doubts, comments, or suggestion, please post your suggestions and comments in the comment section. If you have not subscribed my channel, then I would recommend you, or I would request you to please subscribe the channel. Thank you and have a nice day.